This is a DIY mini digital oscilloscope kit. It's another one of these DIY soldering kits that I've received from my brother. While I have a variety of oscilloscopes available to me, I thought this would be a fun little kit to put together on video. Let's take a look inside and see what we have. Okay, so we have a variety of components in the bag. The most important one, of course, is our PCB here, and this is where we're going to assemble the oscilloscope and solder all of our components. Now, as you can see here, many of these will be surface mount, and so we have a variety of surface mount components right here. So there's some interesting things we can see in these little packages. So I think this one is an LED. We have some resistors. We have some capacitors, and there's an extra capacitor actually stuck in this packet, but this is our main IC. So there you go. Apparently this is pre-programmed. It's a microcontroller. We also have an induction coil. We have some variable resistors here, so multi-turn resistors. An encoder, so this is a rotary encoder, and the associated knob that goes on top. USB connection jack and USB cable. We have a switch and some terminals, including some terminals for the board, some wires and some crocodile clips, or alligator clips if you prefer. We actually have a full-on display module here, along with some pin headers that we'll need to attach some pin headers to for putting on the board. That's going to be our main display. And we also have a two-piece case with a variety of fixing screws to allow us to fix that to the board. Now, usually I would use a conical tip on my soldering iron, but I've switched out to a knife tip for this because this will give me a nice sharp point on one side and a flat edge so I can attempt to solder on the IC chip here. I haven't turned it on yet, so let's turn that on and let that warm up a little bit. We have a very brief leaflet here. I'm not quite sure what it says on the back, obviously. Feel free to translate in the comments. But here we have a QR code which directs us to the instructions, and I've already looked up the instructions for this kit, and they are in Chinese, so I've had to translate those as well for me to make sure I do things correctly. So the instructions say that we should start off by attaching our main IC, and so I think I'm going to carefully remove the capacitor that's stuck in here, and we will get to doing that. So this will be my first surface mount project on the channel. I've done some surface mount stuff before, so let's see how we get on. Importantly, in this corner here, hopefully you can see there is a little divot, and that is the pin 1 marking for this chip. And we need to align it with the pin 1 marking here. What I'm going to do is I'm going to pre-tin these pads, and then I'll attach the IC. Okay, so I finally got that soldered. One of the issues was that I pre-tinned the pads, and then the chip, when I first soldered those pads down, slipped between, and I didn't check. But hopefully these are all connected correctly now. That's usually not something, kind of mistake I would make, but being on camera made it a little bit more challenging. Hopefully I won't have any further difficulties when I end up doing the individual components. Anyway, speaking of those, the next bit to install is the resistors, apparently, according to those instructions. And so this one here is this largish one, and this is a 103, and that goes in the R4 position, I believe. And then we have these other resistors that need to be placed on the board as well. So I'm just going to check where those go, and we'll get on with that as well. So I don't know if you can see this, but I think this one says 103. Certainly does to my eyes. The 103 goes into R2, which I've accidentally already tinned, so that's ready to go. In fact, let's do that one first. This is a much larger 103 resistor, so this will be to support larger wattages. And this one, as I mentioned, goes in the much larger R4 pad here. And these are our 202 resistors, and these ones go in R1, 3, and 5. Okay, all the resistors are now soldered. And considering the fact that I'm doing this from a couple of feet away to try and keep my head out of the camera and without a microscope, I think these are pretty good. So hopefully things are going to continue to go reasonably well. The next thing to put in apparently is the capacitors. And so there are a few different ones of those. I'll just check where they all go and we'll make sure those are placed in as well. So capacitors are actually generally unmarked. If I can get these to focus for you. But fortunately, the supplier here has put 103 on the back of this one because this is a 103 capacitor. And there are only 3 that we need to install, and this allows us to differentiate between the 2 smaller ones. And the 103 apparently goes into position C3, which is just here, so I'm going to do that one next. And the other 2 capacitors here go C2, and C1 is the larger one here. So they're different actual package sizes. So this is the larger one, and this one, this one is the smaller one. So I don't know if you can see the size difference there, but there is indeed a size difference. I'm going to put the smaller one in first because it's nearer the chip. Okay, so our capacitors are done. The next thing to do is the LED, and so that is this package here. So the LED has a green dot on the package because it is polarized. And inside we can see the LED. Now I don't know if this is going to come out on the camera, especially through the packaging here, but on one side of the LED there is a green line. And this indicates the negative end of the LED. But we can double check that with the multimeter once we get it out of the packet to make sure we get it around the right way. But I'm pretty sure the green line is actually the negative. So here's my multimeter. It's in diode test mode. And so we should be able to, if we're very careful, light up this LED. So I think it's a bit hard for me to see under the studio lighting here, that the negative end is currently green on this end, but let's double check here. And there we go. So it's blinking red as I'm touching it. And if I turn it around the other way, we'll get nothing on this way, hopefully. There we go. So again, negative is actually on the green stripe for me. There we go. So we can check our LED one more time to make sure we're definitely in the right way. And hopefully, when we do this, LED lights up. There we go. Next up, we have our inductor here. This is actually quite a large component, so hopefully won't be too bad. Next up, it recommends we put in the USB cable, or socket, should I say, and that is just here. So we have a micro USB socket, and in this case, I think it's just using it for power. It goes here, actually. It's just using it for power, so no issues there. The input here is for the other input terminals, but USB in the USB socket. So finally, some time for some blue tack, I think. Next, we're doing the switch, which is this thing here. Just slides in here, I think. It's a bit of a tight fit. There we go. It's holding in quite nicely on its own, actually, so I think I'll skip the blue tack for this one. Next, we can put in two little test loops just here. So this gives us a sine wave and a PWM, or square wave. Make sure these are going to go through the sockets like so. So next, it recommends us doing the header here. And so here we have a header, and this is for our display to be installed. So I'm just going to pop that there. Next, we have the right angle header for the UART here. And then we have our terminal block, which goes just here. And then we have our potentiometers, or variable resistors, and these need to go in the right way round. So the W204 needs to go in part 1, and the second one, 501, needs to go into part 2. Next, we have to install this rotary encoder, and it only goes in one way, which is good, although it seems these pins here have been bent a little bit in transit, so straighten those out. Okay, and that's all the components on this main board here. So the next thing to assemble is this mini LED screen. So what we do is we open the packet and we take this out. And we can see we have the screen and we have some pin headers. But you'll notice that we also were provided with some separate pin headers here. And that's because it wants us to use the shorter pin headers so that we have a nicer fit on the board. So this goes in here. I am going to put a little bit of blue tack on the back, but I have to be a little bit careful here. We don't want to crack the screen because these are actually usually glass. So you want to be a bit careful about putting any pressure directly on the screen there. Obviously, it does need to go on the back there so that this can plug in, without the blue tack obviously, into this socket. So it looks like everything else is mechanical assembly from here on out, with the exception of this. And so it's given us these little wires here that we can attach to the crocodile leads and pop them in these terminals here. And so these are our test probes. So what I'm going to do here is we need to make sure we take the sleeves off these, pass the wire through, not forgetting to do that, and then solder them in place. But of course I'm going to cut the ends off of these, and then I'm going to need to strip the wire here and we can solder on those connectors. So let's assemble our box. Okay, we appear to be all done. So let's get our USB lead. And we can slide the switch on. And there we go, we have a display. So our CPU must be soldered correctly, our display is obviously connected correctly, power LED is on, so all good things so far. So what we can do now is we can try and get a signal from our test hoops. And so we have a little test hoop down here. So if we just squeeze our crocodile clip, pop it on here, we're getting a nice little signal on here. And I think we can adjust this to get different patterns. So let's try the square wave first actually. Oh, there we go, we have some kind of square wave going on here. And I think these resistors here allow us to adjust the speed. Nothing obvious on this one. Maybe nothing on this one either. We can also control what's going on though, so let's have a little look what's going on here. Ah, there we go, we're controlling the display a little bit there, the sort of resolution. Oh yes, we are hovering over this control here. Let me see if I can bring it a bit closer to the camera. So we're hovering over this control here, and as I turn this rotary encoder, we get different adjustments. So let's see if I adjust these, do we get anything different? No, I'm not sure what these adjustments are doing. So maybe you can see something and you'll mention it in the comments. So pressing it seems to stop it. I think if we move things around as we can adjust things if we hold down while we move things. So auto, normal, and single shot. Let's leave it on auto. There's the speed. And then I think this controls, the range that we're detecting. And this is controlling the trigger point. And that's the settings. So a few different things we can adjust here. Okay, well, let's try the sine wave option here. See if we're getting anything here. And now we definitely have some different behavior. We can do this. There we go. And I wonder if these are only adjusting the sine wave patterns. Yeah, not sure what these are doing. Might have to look more carefully at the instructions there, see if I can work that out. So I also have this function generator that you may have seen in a previous video. And so what I can do as well is connect it up to here and see if we can detect which patterns we're connected to. So we need to connect the ground here, like so. So we can connect to this wire here. And let's see if we can see anything. And so we do indeed, I think, see a square wave pattern there that's going on. Let's see if we can adjust the resolution here. So that's at 100 microseconds, but I'm not really seeing anything happening here. So we've adjusted the range by tapping over this. Yep. Oh, there we go. We can adjust the range. We can't seem to set the bottom one. It doesn't seem to highlight the bottom of the range, but we can set the top. So we can go well over and shrink this right down, or we can go through as well and bring it right the way past. Not sure what this number really means. I assume it means voltage, but I'm pretty sure this is not putting out anywhere near 42 volts. So now, if I start this, now hopefully we can adjust. Oh yeah, there we go. You see, we can adjust what we can see. So I can slow this down. So this is at apparently 2.9 kilohertz. And then that's all the way up to, well, probably exceeding the range available on this device. We can slow it right the way down. And we can also shrink the amplitude by controlling this control here as well. Okay, so let's try and put this in a much lower range. So we can change the frequency here. Okay, and you can see this is kind of pulsing up and down. And yeah, this is in the 10 to 100 hertz range. It says we're at about 14 hertz. All the way up, that says we're now 82. We can adjust our range here so you can more clearly see the waveform. Very nice. So let's try and see if it can do a different pattern. So we have the triangle pattern here as well. So we seem to be getting the top of our triangle sliced off. And I wonder if that's, oh, there we go. It's because of the amplitude control here. So now we can take that down to a nice triangle wave. And if we adjust here, we can get that to fully cover our display. So yeah, nice little mini DSO. Not quite sure how useful it really is practically. It's pretty fiddly to control here with these controls. And as I say, I'm not really sure what this is really telling me, especially with regard to maybe voltage levels. So I hope you found this video interesting, and I hope to speak to you again soon in the next one.